There are questions that appear simple when spoken aloud, yet become more unsettling the longer you sit with them. Questions that do not ask for facts, but for courage. Questions that quietly stretch the mind until it realizes it has no walls. One of those questions is this: what is infinity? And more dangerously, does it actually exist? At first, infinity feels like a word we already understand. It slips easily into conversation. Endless time, infinite space, never-ending numbers. We use it casually, as if it were just a very large quantity, something far away but still familiar. But infinity is not large. Infinity is not far. Infinity is not even a number. Infinity is a challenge to how the human mind works, and for thousands of years, it has terrified, fascinated, and divided thinkers more than almost any other idea in mathematics. Imagine standing at the bottom of a staircase. You take one step up, then another dot. Each step is solid, real, finite dot. Now imagine that the staircase never ends, no matter how many steps you climb. There is always another step waiting above you. You are not moving in circles. You are progressing. Each step is real. Each effort counts. And yet, the top never arrives. This is one of the oldest images of infinity. Not a thing you reach, but a process that never finishes. The ancient Greeks were among the first to feel uneasy about this. They were masters of geometry, logic, and careful reasoning. They believed the universe was ordered, harmonious, and intelligible. For them, mathematics was not just calculation. It was truth made visible. Infinity disrupted that vision. If something never ends, how can it be understood? If a process never completes, how can it be known? To many Greek philosophers, infinity felt dangerous. Not because it was false, but because it refused to be contained. So they drew a distinction. They accepted infinity as something potential, a process that could continue forever in principle, like dividing a line again and again, like counting without stopping. But they rejected infinity as something completed, something that existed all at once. An infinite staircase could be climbed forever, but an infinite staircase that already existed as a finished object felt impossible. Infinity was allowed as an idea of becoming, not as an object of being. And yet, even this careful compromise led to paradoxes. One of the most famous involves motion itself. Imagine you want to walk across a room. Before reaching the other side, you must first reach the halfway point. Before reaching the halfway point, you must reach the quarter point. Before that, the eighth point. This division never ends. So how can motion ever begin? You seem trapped in an infinite sequence of tasks before you even take the first step. And yet, you walk across the room effortlessly. The paradox does not deny. Experience. It exposes a tension between experience and logic. Infinity lives in that tension for centuries. Infinity remains something to be handled with caution. It appeared in philosophy, theology, and metaphysics more than in mathematics. In religious thought, infinity became associated with the divine, something beyond human comprehension, something absolute. Mathematicians often preferred to look away. They built systems that worked without needing infinity to exist as a completed thing, until they could no longer avoid it. As mathematics evolved, thinkers began to explore patterns that repeated endlessly, curves that folded into themselves, shapes that revealed new detail no matter how closely you examined them. Imagine a fern leaf. Zoom in on one small section, and it looks like a smaller version of the whole leaf. Zoom in again, and the pattern repeats. No matter how far you go, the structure continues. This is not infinity as distance. This is infinity as depth, a never-ending richness contained within a finite space. It is both beautiful and unsettling. Your eyes see a boundary. Your mind finds none. Now imagine standing beneath a night sky. Stars stretch in every direction. No edge is visible. Is space infinite? Or does it curve back on itself? Human intuition breaks down here. We are creatures of limits. We live in bounded bodies on a bounded planet, during bounded lifetimes. Infinity does not match our instincts, and yet the universe does not seem obligated to respect them. The most shocking moment in the history of infinity came when mathematicians dared to ask a forbidden question. Not just whether infinity exists, but whether there are different sizes of infinity at first. This sounds absurd. How? Can one infinity be larger than another? If both never end, how can one contain more than the other? This idea shattered intuition completely, and yet, it turned out to be true. Imagine counting whole numbers. 1, 2, 3, 4, and so on. This list never ends. Now imagine counting fractions. Between 1 and 2 alone, there are infinitely many fractions. At first glance, it feels obvious that there should be more fractions than whole numbers. After all, fractions are everywhere. But mathematics revealed something shocking. You can match every fraction to a unique whole number, even though both lists are infinite. They can be paired perfectly, 1 to 1. This kind of infinity has a strange property. It is endless, yet countable. Now imagine something else. Imagine all possible decimal expansions between 0 and 1. No matter how you try, you cannot list them all in a sequence. There will always be numbers missing. This infinity refuses to be counted. Even in principle, it is larger, not longer, deeper. This discovery shattered the old belief that infinity was a single, vague concept. Infinity had structure, hierarchy, variety. Some infinities were strictly larger than others. This was not philosophy. This was mathematics, and it was terrifying. Many mathematicians resisted this idea fiercely. They argued that it led to contradictions, that it relied on abstract reasoning divorced from reality, that it opened the door to paradox and madness. But the logic held. Infinity was not chaos. It was precise, unforgivingly precise. The problem was not infinity. The problem was intuition. Infinity forces the mind to confront its own limits. We are comfortable with numbers that can be reached. Infinity cannot. We are comfortable with processes that finish. Infinity never does. We are comfortable with objects we can imagine all at once. Infinity refuses to fit inside imagination. And yet, mathematics does not require imagination to obey comfort. It requires consistency. There is a quiet irony here. Infinity feels mystical, but it is one of the most rigorously studied concepts in mathematics. It does not bend to poetry. It does not care about fear. It simply is what logic allows it to be. And this brings us back to the most unsettling question. Does infinity exist? Or is it only a product of the human mind? Is infinity a feature of the universe? Or a tool we invented to describe what we cannot finish describing? there is no final answer. Some believe infinity exists independently of us, that the universe is infinite whether or not we think about it. Others believe infinity is a concept, not a thing. A way to talk about unending processes, not completed realities. Both views have consequences, and neither can be proven decisively. Perhaps that is the true power of infinity. Not that it gives answers, but that it forces humility. Infinity reminds us that mathematics is not just about control. It is about confrontation. Confrontation with ideas that do not fit inside human scale. Ideas that stretch reasoning beyond experience. Ideas that show us that understanding does not always mean containing. When you stare into an endless staircase, a star-filled sky, or a repeating fractal, you are not just seeing patterns. You are seeing the boundary between what the human mind can grasp and what it can only approach. Infinity lives on that boundary, forever just out of reach, forever shaping how we think. If this story unsettled you, that is not a failure. That is the point. Because infinity was never meant to be comfortable. It was meant to remind us that mathematics is not only about certainty, it is also about wonder. And sometimes, the most honest answer mathematics can give is this. The question goes on forever. Stay curious. This is Maths Whisperer.